Hello friends, welcome to the e-course on microirrigation. Today's lecture is on automation in microirrigation. I am T.B.S. Rajput, Adjunct Professor at Agriculture Engineering Department of Indian Agriculture Research Institute, New Delhi. I am specialized in soil and water conservation engineering, and my current interest is on microirrigation. I have over 40 years of experience in research in agriculture water management and teaching, postgraduate teaching. I have got several recognitions based on my work. The best teacher of Indian Council of Agriculture Research, and then Rafi Ahmed Kidwai Award for research. Just to introduce, today's lecture will include advantages of automation in microirrigation system, types of automation systems in microirrigation system, components of microirrigation automation systems, and then on-demand irrigation system and Indian efforts in MIS automation. Let's start from microirrigation system itself. We all know it is advantages. Just to refresh yourself, microirrigation advantages include low application rate, controlled application rate, uniformity of water application. This is the system that gives you the highest water distribution, water use efficiencies, uniformities, efficient fertilizer application, control of root zone environment, crop yield enhancement, and then quality of the produce gets improved, and discourages weed growth because it does not provide water in between the plants where the weeds grow. Saving of irrigation water, lesser use of power, reduce labor costs, and is suitable for difficult land terrains, because if the terrain is undulating, it cannot be leveled, then surface irrigations are just not possible. But microirrigation make it possible to irrigate even very difficult terrains. Why do we need to think of automation in irrigation? Is basically to optimize the consumption of energy and water in agriculture. Microirrigation offers huge possibilities for automation. And why it is so? It is because the flow is in closed conduits, and a better control of flow is possible in closed conduits. Types of automation may include semi-automatic and fully automatic. In semi-automatic, several operations are there which require the human intervention or human activity or human control. And fully automatic systems, they normally operate by themselves and do rarely require any human intervention. Now, we were talking, why do we need automation? We need automation for several advantages, and those advantages include automation eliminates manual operation to open or close valves, because there are pretty good chances of missing the timelines and not following the exact schedules of opening and closing the valves. So if they can be done automatically at predetermined times through automation, we can definitely optimize on water use. Possibilities to change frequency of irrigation and fertigation process, and also to optimize these processes. Now, automation gives enough flexibility of changing the processes and timings of irrigation and fertigation. Now, adoption of different advanced technologies, they are very good apt. They are apt for automated systems, and automated systems are good for adopting new technologies. Increased water and fertilizer use efficiency, as I told, if water efficiency is high, it's likely that we will be able to achieve higher fertilizer efficiency as well. System can be operated at night time, and which saves the daytime for the farmer for taking up other activities. And pump starts and stops exactly at the time when you really want them. That makes the irrigation water optimization, and that is important, and that's how the water is saved, further saved by automation in micro-irrigation systems. But in Indian context, I would like to add a few more things. So far as India is concerned, automation for micro-irrigation system is becoming quite popular. And there are two distinct reasons for that I want to add, which are not common to other countries, which are very specific to India, I will say. Maybe other countries, they also have this problem. Number one, the power cuts. In India, the power cuts are quite common. And we are getting the controllers or automation components mainly from developed world, which have not known, we don't see the power cuts, and the components or the products that they prepare do not have that flexibility of getting adjusted to this situation. So this is a very specific requirement in India that our automation systems must be capable of handling. The second is supply voltage variation. It's not only the power cuts, but the variation of the voltage that is a major issue. And normally the controllers, advanced controllers, do not have inbuilt voltage stabilizers. So that makes it as a special problem in Indian context, and I wanted that I would highlight. There are basically three types of automation systems. Number one, they are time-based. Number two, they are volumetric measurement based. And number three, they are real-time feedback based. Now, time-based is simple, that we prefix the operation times for different parts of the field, and then let the system operate at that particular timings, maintain those timings. In case of volumetric based, we predetermine the volumes of water to be allocated to different parts of the field, and then we install the water metering and controlling valves, hydraulically or electrically operated, and then the predetermined amount of water is allowed to pass through or get allowed into a particular part of the field, and then to other field. And third is the real-time feedback systems, that they get the feedback from the fields about soil moisture, crop or crops requirement or whatever, and then based on that the system is operated for that much of time and then goes to the next part of the field. If we take into the the type of the systems from construction and from the principle of operation pattern, then they can be open loop system or closed loop system. Open loop systems are those where the decisions are made by the operator, and operator sets an irrigation schedule, and all further actions are taken by the operator himself. And in closed loop system, a general strategy for the control is defined by the user or the operator at the beginning only. Afterwards, all the actions and decisions are taken by the controller itself, depending upon the feedback from the sensors. Now, seeing these systems further, open loop systems could be of different types. Let's say open loop on-off irrigation control system. The figure A, that time is set by the operator, that is only one variable. You can see that the operator valve is given and he fixes the time once. So this is called the open loop on-off irrigation control system. Now the second is open loop stepwise irrigation control system. Now preset irrigation volumes are available now. In this, you can just see figure B. In place of operator control valve, in addition to that, we have a unit where shows the volume of water, the first flexibility or the possibilities of fixing predetermined value of volume of water. And figure C says open loop continuous irrigation system. An infinite number of irrigation variables are available, and this volume itself gets adjusted as per the inputs of those particular parameters. Now closed loop system, feedback irrigation system using soil metric potential as the control of variable. Time variable is used to adjust the amount of water being applied. Means what? Mainly the amount of irrigation water is controlled by the soil moisture status or soil moisture deficit through any sensor indicating the metric potential of the soil and directing the amount of water to start from metric potential which is available from the soil to the predetermined or whatever is the desired level of metric potential that you want. Normally you wanted to put it near field capacity. Then rest of the variables, particularly the time, is adjusted only to adjust the amount of water. Depending upon the capacity of the system, you fix the time now that this much water will go. So this is what the closed loop system, feedback irrigation system is all about. Now, based on type of control, it could be sequential system, it could be non-sequential system. In sequential system, it could be hydraulically operated, it could be electrically operated, or it could be operated using both the principles. Similarly, in non-sequential systems is a feedback control or inferential, or it could be a combination of the two. So we will discuss one by one. Let's see in the next slides. Now, sequential and hydraulically operated automated systems. You remember in sequential we had said there are three types: hydraulically operated sequential, electrically operated sequential, or combined hydraulically and electrically operated sequential systems. Here we are talking of sequential hydraulically operated automated irrigation systems. Now the sequential system is particularly suitable for micro-irrigation system. At each connection to the main line, a unit consisting of the water metering valve and a hydraulic valve are located. So at any takeoff point from the main line, that means any submain going from there, at the head of the submain, we install two things: the water metering device and a hydraulically operated valve. And the amount of water is set according to crop, soil and climate. And then metering valve closes after it has released the quantity of water that we wanted to allow to the particular part of the field. And then the pressure at this valve gets released and it closes this particular valve, and the irrigation gets into the next, or sequentially the next outlet, next valve. In soil moisture based feedback control systems, the main components of the feedback control systems will include soil moisture sensors, and then electronic control unit will be an additional part, and for controlling the flow the solenoid valves will be used. For taking decisions or on your behalf, microprocessor computer will be required. Now in this particular system, a sensor is important to indicate to the microprocessor what is the soil moisture status of the soil. And if you have prefixed the soil moistures, then it will indicate to the controller that it has dried enough for the next irrigation, and then the irrigation will start. And the irrigation will continue till it reaches again the predetermined soil moisture level. Now these sensors are connected through proper interfacing circuit to the central control unit, which could be microprocessor or a computer with a program to take irrigation scheduling decisions. Now irrigation scheduling decisions, as I told, are taken by the microprocessor on the basis of the soil moisture status and predetermined conditions of soil moisture for beginning irrigation and for ending the irrigation. Now in inferential control systems, the main parts of inferential control system are sensors for measuring various climatological parameters such as solar radiation, maximum and minimum temperature, wind speed, relative humidity, pan evaporation, etc. This system makes use of various evapotranspiration models to estimate evapotranspiration of crop using different climatological parameters. The estimated evapotranspiration is used to schedule irrigation. The solenoid valves are operated using inferential circuit and relay switches to put on or to put off the irrigation system. What actually it does? This particular system has all different type of sensors for monitoring different climatic parameters. And then all the values taken from these sensors, particularly climatic parameters, it computes the evapotranspiration using any of the models. There are several models for estimating evapotranspiration based on the climate parameters. And once it calculates the requirement, then this requirement is supplied and regulated through solenoid valves installed at different takeoff points of different parts of the field to be irrigated. Now, in case of real-time feedback systems, the application of irrigation is based on actual dynamic demand of the plant itself. Now, plant root zone effectively reflecting all environmental parameters acting upon the plant. Operating within controlled parameters, the plant itself determines the degree of irrigation required. Various sensors like tensiometers, relative humidity sensors, rain sensors, temperature sensors, etc. control the irrigation scheduling. These sensors provide feedback to the controller to control its operation. Now, we have said that these sensors are required, and these sensors will estimate how much water is required. But in the first part of the narration, we said that plant itself will indicate the degree of irrigation required. And how is that? There are different types of sensors we'll be discussing later, and they are, for the time being, just mention the name. They will be phytomonitoring techniques. That is, the techniques to determine the water pressure, leaf area index, stem pressure, stomatal pressure, and different plant properties or plant reactions or plant characteristics which indicate the required quantity of water. That what is the soil moisture, the moisture status of the plant, or moisture health of the plant, and then how much more water it needs. So real-time feedback systems could be based on either a number of sensors listed here as we discussed, or any of the phytomonitoring techniques that we'll be discussing a little later. Now, fully automatic systems enable the control of several valves coupled with fertilizer injection systems, flushing of filters, input from sensors, monitor soil water status and plant water status and evaporational demand. The important thing in fully automatic system is not only controlling the irrigation water application, but they also take care of flushing of filters that is required. They automatically flush it, and then they are also coupled with the fertilizer injection systems. They operate the fertilizer injectors and close the fertilizer injectors as per the predetermined quantity of fertilizers they have been indicated to apply for the field during the irrigation. And the introduction of more sophisticated controllers or general purpose computers for irrigation control and management requires feedback for control, performance assessment, and decision making. Now we can achieve everything in automation, right from fully automated to semi-automatic or sequential or non-sequential, open loop or closed loop, through different components. And those components include flow meters, maybe automatic valves, whether they are hydraulically operated or electrically operated, and pressure gauges to monitor particularly the flushing part. When we have to install the auto flushers, then auto flushes operate on the values of the difference of the values of pressure gauges installed on both sides of the filter, and based on a given value of difference. Exceeding the difference means the filter is consuming more energy and creating more head loss. They start operating. So pressure gauges are important, and controller, of course, is required all the time. Solenoid coils are always important to convert the electrical signal received from anywhere into hydraulic signals. And by just working on the electromagnetic principle, a solenoid valve, given the electrical signal, makes it magnetized and opens and closes the valve, or the floating type of valve, not a floating but moving plate type of valve, and this valve plate is moved by the magnetic force created by the electrical pulse, the electromagnetic force. And automatic metering valve is important, particularly to ensure that a metered and known quantity of water is permitted to go to the field. And sensors can be of different types and for monitoring different parameters, as we have discussed earlier. See, the control is the heart of the automation system. Each coordinates operation of the entire system, and the controllers may be programmed to run different zones of the field or different areas of the field, sub-areas of the field, based on time, based on volume of water, or based on any other parameter, but they control as per the input provided. Now, control valves are the valves which permit the predetermined value of water to move out, and their operation automatically on and off operation is based on the predetermined values that they are. They could be hydraulically operated, they could be electrically operated, and solenoid valves we have seen that solenoid valves are important to open and close the valves through the electrical signals generated by either some sensors or some controllers or whatever way, timers. Similarly, there are a few more components required. Particularly, we'll see the flow sensors, and flow sensors are important that along with metering the flow, they control the flow as well. And then soil sensors are many, not only one, but we'll be discussing them in detail. But for the time being, only two are shown here in the picture, so you can just see a tensiometer and a gypsum block. Tensiometer it measures the soil moisture tension. And how does it do? It's a very simple phenomena. That is a tube, is a vacuum created inside the tube and then sealed. And in fact, at the one end, at the bottom of this, is a porous cup, and the whole tube is filled with water, not a vacuum created, and then it is sealed from outside. And then it is installed in the soil, and once it comes in the contact with the soil, the porous cup allows the water to flow from the tube to the nearby soil area, and it starts creating vacuum in the tube. And when the equilibrium arises between the suction created by the soil and the vacuum created in the tube, it stops moving further. The water stops moving further, and the vacuum is shown by a vacuum gauge installed in this, and that's how we interpret what is the soil moisture, soil suction at that point. And for other things, for other soil sensors, we'll discuss here. Now, the sensors, they could be in different shape, different sizes, for different purposes. But basically what we need, they could be electrically operated, electromagnetic, they're optical, mechanical, and airflow or infrared sensor for plants. All different sensors, they are sensing a particular parameter, either soil moisture or suction or any plant parameter and conveying it to the controller. And then further decisions are taken by the controller on the fixed values given to the controller for opening and shutting the system accordingly. Now, soil moisture sensors, I was telling that tensiometer we discussed, resistance block and gypsum block, they're almost the same. It uses the principle of changing resistance of soil within the soil based on the soil moisture content. So if you put two probes and then measure the resistance between the two under different soil moisture conditions, you get different resistance values. And that's what the principle is, and that's how the soil moisture is interpreted. Granular matrix is not that common, but TDR based soil moisture sensors. TDR is a time domain reflectometer. It works on the principle of a scattering. The energy is scattered from a source and then returned back, received back, and then it interprets how much resistance it felt, and it interprets into the soil moisture system. Airflow sensors, infrared sensors for leaf area temperature. They are the thermometers, or they are the temperature meters of leaf or canopy, plant canopy, from a distance. And sometimes they also tell the difference between the temperature, ambient temperature, and the temperature of the canopy. And then sensors for climatic parameters. There are many metering pumps and master relay and several other components we'll discuss and see. You can just see a whole lot of different components. You can just see on the net. You can find all different shapes and sizes of all these different sensors. Coming to basic structure of irrigation control system, different functional models are required, and they are suggested by Wang in 2013. And it says in the center is the irrigation controller, and is a programmable device, analog interface, analog or digital converter, or communication. This is the central part, and the information is fed to this particular unit by geospatial maps and GPS, fertilizers and pesticides, then irrigation execution, the time, the flow meter, solenoid valve, transducers, they all feed this information into this. And then booster pumps, water supply systems, and then water content determination of soil sensing, plant sensing, climate based, and water balance based. All these models feed into the central irrigation controller, and this way it makes a complete automated system. And finally we can have something of this sort, that all information from different quarters, from different maybe plant, maybe soil, maybe system, control valves, regulators, that gets into the central unit. And that central unit, again, on the basis of that, it controls the controlling units like the valves, the flushing things for auto flushing, and flow metering, how much flow is gone, and all sort of predetermined things are done by the controller. Well, these are all very positive points that we have discussed about the automation, but there are certain precautions we must take while using automation system. Number one, install the controller at eye level. This will help and facilitate easy programming and reading the screen. Always we keep voltage stabilizers to protect control from the voltage fluctuations that I told is a special problem with respect to India, or it could be other places as well, but voltage stabilizers are must, and always earth the controller for avoiding shock and things that kind, and use conduit pipes to carry the wiring. Do not leave the wiring just open, and do not just bury them as such. Put them in a proper conduit. Avoid installing controllers in rooms where heat and moisture are problems. Protect the controller from water. Water should never touch the controllers, otherwise it can short circuit and it can create also a problem. Protect the controller from insects, lizards, frogs, and other reptiles. Flow control systems are not meant for on-off operation, but used for fine-tuning the system by adjusting the pressure or flow. As far as possible, install the controller near to the water source. This will help to keep an eye on everything at one place, and it will be a good monitoring of the whole system, including the water source. Well, this is one of the devices available. Most of the manufacturers have developed these sort of devices. This is the one developed by Netafim, and they call it a NetaJet. And it is a state-of-art automation system. It has the programmable. It is programmable for maybe sometimes for the whole crop season, and then it has got provisions of fertigation of 3 nutrients or 5 nutrients, and then each nutrient is connected with a solenoid controlled venturi, and this is all programmable. So not only irrigation, but you can also schedule your fertigations, and not only with one nutrient, but 3 or 5 nutrients depending upon the unit that you have with you. It is also equipped with water meter. It's also equipped with different type of filters, and then it has the different number of valves it can control, and depending upon the type of unit and the size of the field that you are going to have. So this kind of units and this kind of automated control units are available in the market, and depending upon the need of a person of a farm, any of these units can be made use of. An important development is on-demand irrigation. And this on-demand irrigation is that let the user identify or fix its own demand, and if it's a group of users and we do not know how much who will need when, then an arrangement is done to have a closed loop of pressurized water available, and the outlets given at different locations for different fields. And a person, if he needs water, he just puts a card, a preloaded card like your ATM or a debit card or anything, and then whatever worth value you want, you fix that in that meter that you want 20 meter cube of water or 200 meter cube of water. You will be charged accordingly, whatever the rates they have fixed, and the outlet will apply or allow that much water out of it, and then it will close automatically. So this is one of the ways to minimize the water losses, and this type of systems are being really appreciated, and I hope that they will have better market or more better future for that, sir. I was talking of phytomonitoring application, plant parameters that direct how much water really plant needs. And that could be a sensor from the leaf, by monitoring the leaf, sensing the leaf and leaf water potential or things or parameter of that kind, indicating how much water stress the leaf is feeling and how much more water should be made available to this leaf for its proper functioning and economic benefit. And then this next one is from the fruit. The fruit shine and fruit moisture content also is a good indicator of plant water health, plant water status. So you can measure that, and particularly the force, the pressure generated by the fruit, and then it can be interpreted into actual water requirement of the plant. Similarly, at other organs, stem and other places of the plant, this technology is available, and they can be used for monitoring different plant parameters for interpreting the actual water need of the plant. If we advance from automated irrigation to precision irrigation, then we have to see the gap and the lacuna in microirrigation system, which perhaps is not capable of achieving precision in irrigation. What I mean that yes, you can match the water requirement of the entire area to predetermined area, and you can also adjust the discharge as per along each lateral. That is fine. But if the water is to be applied in differential quantities along the lateral, it is not possible in microirrigation system. But a center pivot system that you are seeing is capable of achieving that. And how does it achieve? Because if you see the circles, they are the maps showing the soil moisture status covered by the center pivot. Now this map shows different colors. These different colors indicate different water requirements. And in a center pivot, the nozzles are programmed to deliver at a particular discharge. Then only you can have the uniform water application throughout the area by adjusting the nozzles. They are keeping the discharge in proportion to their travel distances and in terms of time. Now the first nozzle on the arm of the center pivot moves around the center very little, whereas the last nozzle covers a large distance around this, but the depth of irrigation at both the places is planned or designed to be same by adjusting the discharges of the nozzles. Now since each nozzle is programmed to do a particular discharge and the speed of the movement is under our control, then it is possible to program the entire center pivot to apply known quantity of water at known points in the field. That is site-specific irrigation or precision irrigation, and that is achievable by a center pivot. So this is just an idea to give that how the precision irrigation in large areas possible. Government of India is investing or is planning quite a lot of money to improve the water use efficiency in canal-based irrigation systems, because at present it's quite low. And for increasing that, we'll have to address the causes of low water use efficiency in canal-based systems. I cannot get into that lecture at the moment, but specifically addressing only one point, that water distribution in the head reaches and tail reaches is not uniform because of several systems difficulties and the users' perceptions and users' difficulties. Now, if we have to apply, or if we have to provide the irrigation water in adequate quantities to the end reach farmers or tail reach farmers, the Government of India plans that tertiary system is connected with micro irrigation systems, and whatever the little quantity reaches the tail end is stored in auxiliary reservoirs, and from those auxiliary storage reservoirs the water is applied through micro irrigation. So if we have to introduce automation in canal irrigation systems, it has to be from the top to bottom. So what you are seeing in the picture, they are the possibility of automating the entire large canal systems coming to the distributory headworks. This is a depth reach wheel, and this is a control gate, and this is a small solar panel to operate this as and the programmable device. This wheel, depth reach wheel, measures the flow, and these gates can be opened and closed by the sensor, by the photovoltaic panel, and the sensor attached to that on after releasing the fixed amount of water. Normally the amount depends on what is the volume taken and what is the charges for that. We have a difficulty in India of charging for volume of water because water is not yet priced, and whatever little price was fixed much earlier, that also is not being practiced because of mainly political and social reasons. So automation can be done at different levels, from you have seen the canal heads to distributory heads to outlets, and then finally to at the field level. And now if we come to the sensor based irrigation scheduling, then it could be you are seeing automatic weather station monitoring all weather parameters and estimating directly the crop water requirement, and then connected with the automation system. And nowadays we have the mobiles, GSM technology. We can have the signal or the message when to start and when to stop the irrigation. So it could be monitored remotely from any location, anywhere, and then the sensors like tensiometers and diviners for soil moisture movement could be used for very precise monitoring of soil moisture and controlling the irrigation water application accordingly. The tensiometers, we did a lot of studies on tensiometers, the farmers, and they said only one thing: the tensiometer is good, but the dial which indicates the vacuum is difficult and cumbersome to read, and they were averse to that. So what we decided to remove this vacuum gauge, and if we removed this, we needed a longer tube, and just having the tube, not the vacuum gauge, and then instead of we found that works very well. We called it Irrischeduler, and that particular device, simple device, after removing this, we tested in different soils, and then it was accepted for as one of the irrigation inventions, and it was selected for presentation in one of the irrigation shows every year arranged in United States. Taking it further, we saw when the water level is changes, and then different levels of water indicates different soil moisture conditions. We provided the units at the different levels, the conducting units, and then we started it automating that if the water level reaches a particular level here, then the circuit gets on and it starts irrigating. And when it reaches a particular level here, that the water supply is shut off. And so only on that basis, and using the GSM transmitter, and we developed a automated system, and it is working very well. Then the same sensor, using the same sensor, we made use of that in the reservoir, let's say from where we are pumping, if we can put two different levels that will allow the supply or the pumping when the water level is at the level A until it reaches the level B. So we can fix the two probes at two different points A and B, and automatically the pump gets started and shut off based on the water level in the reservoir. That also has been tested successfully using simple the GSM transmitter, GSM receiver, and then this is the wireless pumping unit that finally has come out. There are some of the developments in making the system automated, irrigation system automated economically. Some efforts have been done by Indian Institute of Technology, Kharagpur, and they developed a simple device using a YouTube manometer and providing the probes at two different arms of the manometer to start and shut off the system based on the levels of the mercury reaching this and showing a particular tension in the soil section. So with that we have covered the automation basics, and I'm sure the other two lectures, there will be another two lectures on installation, operation, and management of the system in which they also can come up on different automation devices that those manufacturers are making. And if you still have some questions, yes, they will be addressed as and when any opportunity comes for personal interaction or through webinar. With that, thank you very much for this class, and we'll meet again. Thanks.